Thank you to all the subscribers. And if you have not already subscribed to my channel, please subscribe to my channel. And in today's video, we are going to see how to set up a AWS ALB with a sample Lambda target, which returns some kind of a dummy response, and then enable HTTPS to that AWS ALB. And this is a series of a video where I will publish another video on how to secure the same AWS ALB using a OpenIDConnect provider like Cognito or even an Okta. So in order to secure a AWS ALB using a OpenIDConnect provider, the basic prerequisite is to enable HTTPS, and that's what we are going to do in this video. And so I am already logged into my AWS console. You can log into your AWS console, and please note that I am using the new AWS console. When you log into your AWS console, if you are still using the old version, it might ask you to switch to the new version, or there should be some other option to switch to the new version, a button to switch to the new version. But if you still want to continue using your old UI, that is also fine. The only thing is these configuration screens will look slightly different, but you should still be able to follow these steps. So let's go to the EC2 service and create AWS ALB. That is the very first step that we are going to do. So if you go to the load balancers in EC2, there is an option to create a load balancer. And we are going to create a application load balancer in this case. And you can give any random name, which is something like I'm going to give OIDC ALB. And you can leave the default VPC, which is internet facing. Just make sure it is internet facing. You don't, like, these are all the default options, so you can basically leave it, but just make sure it is internet facing because we want to test it. And let's select a couple of regions, because AWS ALB expects at least not regions, couple of availability zones. AWS ALB expects at least 2 availability zones, so you can select the first 2 availability zones which is showing up in your screen. And then let's leave this default security group. Let's remove this and let's create a new security group for this ALB. Let's name it as OIDC ALB SG HTTPS. Enable HTTPS access and add a rule, and in this rule select HTTPS, and you can select 0000, that is, which means like anyone can access this ALB in the HTTPS port. So let's create this security group. So now it's done and it's called OIDC ALB. Just copy the security group and go back to this configuration screen. You can close this and you should be able to, okay, you need to refresh it because sometimes it doesn't show up. So once you refresh, it shows up, and now we have configured that security group. Just make sure the default security group which was showing up before, just make sure you remove it. We only need this security group at this point of time. And let's change this protocol. The default listener is HTTP protocol. Let's change it to HTTPS. And the next step is, if you look at here, we don't have any target group, and it expects a target group to even launch a new AWS ALB. So let's open this in a new tab and create a target group. And let's use this Lambda option. And in the Lambda option, it asks for a name, and we will give OIDC ALB TG, which is basically a target group. and we don't have any function. I don't have any function. This is some old function which I wrote, but I don't have any specific function which I can use for this target group. So let's go ahead and create a function. So what we want to do with this function is basically when a request hits the Lambda, it has to return a response, a HTTP response. Uh, and then the AWS ALB will forward all the requests to this Lambda, and whenever the Lambda receives the request, you can implement your own business logic and then return the HTTP response in that Lambda. So let's create a Lambda function using the blueprint. So let's use this hello world. Select this hello world, configure a Lambda function, and let's name it as OIDC ALB response. So this is the default source code in this Lambda function for this hello world. Now we want to return a HTTP response, but if you look at this response, it is not a HTTP response. It is just some, it just returns the value of this key one, which is not what we want. So if you go to Google and search for AWS Lambda ALB target, the very first link that you see will be a Lambda functions as targets for elastic load balancing. Click that AWS documentation, and if you scroll down, you will see a section called respond to load balancer. So if you see this response, this is the kind of response that a load balancer expects from Lambda function. So let's copy this and go back to this Lambda function. We don't need all this code, remove it. So we can't do it here. Let's first create the function. So the function is created now. Let's wait for it to load. Yeah. So now we have the source code. Let's delete this code and just create a variable called response equals that whatever I copied from that previous page. So now we have a this response, and just add return response. So that's it. So what this function basically does is whenever any request hits this function, it will just return a static response for now. So in the body, if you look at the body, currently I am actually, it's returning actually what you say, hello from Lambda optional. Actually, if you do your control Z, there was a source code. Let's actually take this value json.stringify, because we need this for what you say in the return statement. I will let you know like what needs to be done. So right now it returns a static response. So instead of this static response, let's replace it with json.stringify of the event. So basically what this function will do is it will return the HTTP response in a JSON format, and the body of that response will be the JSON representation of this event object, and we will see how it looks once we complete the end-to-end configuration. So as of now, just deploy it. So this function is now deployed. Let's actually try to test it. So let's keep the template as hello world, event name as, just put it as test, and create a test case. Now when you test it, so if you test this function unit, it's basically like a unit testing, you will see this response, static response, and here you can see all the values that are coming in the body. So it's basically the event object. So the event object has this values, and that's what I'm actually doing a json.stringify of that event object, which actually converts all the values within that event object into a JSON response. So now this Lambda function is ready. We need to configure this Lambda function in this target. So let's go here and choose the Lambda function. Unfortunately, sometimes it doesn't get refreshed properly. So I would suggest go to enter a Lambda function ARN option. Go back to this Lambda screen and you will see the function ARN here, right? Just copy this and add it here, and then create the target group. So the target group is now created, and if you go to the target group, you will see it is still unused because the target group is not yet configured in the AWS ALB, which we will do in the next step. But before going there, you can check all the default values that are available in these tabs, uh, like tags, attributes, health check, all those things. So the key thing is the health check. Currently, if you look at the health check, it is disabled. Let's edit the health check, enable it, leave these options, health check pattern as default, and go to the advanced settings. Let's reduce it because we are just doing a testing. We don't really need such a high number of consecutive health check success response to make it green. So let's reduce everything back to what you say, the default, the minimum value, which is shown in this below the text field. So save the changes. So now the health check is enabled, but the target still shows unused because we have not yet configured this target group in the AWS ALB. So let's go back to the AWS ALB and let's refresh, and you will see this target. So this step is done. So until now, just to recap, what we did is we started creating a AWS ALB, internet facing AWS ALB in the default VPC with a couple of subnets from two different availability zones within the VPC. Then created a security group which allows only HTTPS requests to this ALB. And then we added a listener for HTTPS and removed the old listener which was HTTP. So now we have only one listener which is a HTTPS, and for that listener we created a target group with a Lambda function which returns a HTTP response. So the next step is, since this is a AWS ALB which supports only HTTPS, you need a certificate to uh, to even create this ALB. If you look at this, there are some options where you can select a certificate from your AWS certificate manager or identity access management if you already have any existing certificate. But I'm going to show how to create, how to import a self-signed certificate. Again, this is only for testing purpose. When you build a real application, then you need a proper signed certificate which matches with your website domain. Or otherwise it's going to be an untrusted website. No one is going to access your website. But this is just a demo. So let's use the self-signed certificate option. And so here you select import, and here instead of to ACM, select to IAM. So now I have to create a self-signed certificate. How to do that? You can use OpenSSL if you are already aware of how to use OpenSSL to create a self-signed certificate. But I'm just going to use an online website where you can, called SAML Tools, where you can create a self-signed certificate. So let's go to this SAML Tools. So this website is maintained by a company called OneLogin, which is again an identity product similar to say Okta or Cognito. So here click obtain self-signed certificate, and here you can give any, like, whatever you want, like whatever Texas or something. So I will give my YouTube channel name here, and then the common name or domain. It doesn't really matter because it's just a self-signed certificate. But again, you can, maybe if you want to match it with your load balancer name, you can give that. But basically, you can give anything. That's and generate the self-signed certificate. So If you look at the certificate, you have a private key, you have a X509 cert. So copy this private key value from here, like copy it from here, go back to this AWS ALB, give give a name for this certificate, copy and paste that private key here in the private key field. And as I said, if you're using a old AWS console, it might look slightly different, but the concept is exactly same. Then copy this 509 cert, put it here. So now I think we are done with all these steps. Let's try creating this load balancer and see what happens. Yeah, I don't see any errors. So looks like the creation step is successful. Yes. So let's wait for this load balancer to get provisioned. But while it is getting provisioned, we will see certain things like so if you look at here, this load balancer has a DNS name. So this is the DNS which we will use to access this load balancer, and I will show that once the provisioning is done. And it will take few minutes, not like very long time, but it will take few minutes. But while the provisioning is going on, let's go and check the target groups. So if you look at the target groups, if you remember, it was showing as unused before. Now that we added the target group to that load balancer, the health status changed to initial, and if the health checks are successful. So basically here, if you look at this health check, what it does is it will call this Lambda function, and from this Lambda function I am returning a status code of 200. It's a static status code, but in reality you will have some kind of a business logic here which will do all the calculations or any business logic that you want to implement, and then finally return a HTML response with either 200 or something else, whatever makes sense. But in this case, just for demo purpose, I am returning a static response with a status code of 200, and the body as the JSON response of this event object, the JSON representation of that event object. So if I go to this target, yeah, it's still checking the status. Let's wait for. So right now it shows none. I think it's because of it didn't get refreshed. Yeah, so if you look at this load balancer, now it changed to OIDC ALB. And it is still provisioning. Yeah, sometimes it might take even 3 to 4 minutes or even 5 minutes. I don't know, but so while it is provisioning, let's copy this DNS name, and I'm going to use Mozilla for testing because I'm using Chrome for all these configurations, and it's better I use a new browser for testing. So I will use Mozilla for testing, and I will actually go here. Let's just put HTTPS : the DNS name which I copied from the ALB. Looks like it is already provisioned because I'm getting this. If you get to this screen in Mozilla, then it means the AWS ALB is already provisioned. Otherwise, it won't even show this screen. And the reason why you are seeing this potential security risk is because it is using a self-signed certificate. If it is a real website where you have a signed certificate from a trusted certified authority, and then the certificate matches with your domain, you won't even see this kind of an error. But this is a self-signed certificate, that's why you're seeing this error. And if you want to read the certificate, you can go here, connection not secure, more information, and view certificate. You will actually see the certificate which I created in the SAML tools website, with country as US, state as Texas, organization as Security in Action 101, with a 365-day validity. So you can check this certificate if you want, but now I will just say accept the risk and continue. got the response. So if you look at the response here, this is the data which is written from that Lambda function. So if you remember, and if you go back here, I guess it is already provisioned. Yeah, it shows active and it shows healthy. So that's great. Like we didn't have any issues. So if you look at this Lambda function, it actually returns body, which is a JSON representation of this event object. And this is actually this JSON representation of that event object. And here you can see some headers which are being passed from the AWS ALB to that what you say to that Lambda function. So basically, if you look at here, there's a query string parameters, right? So for example, let me try passing a parameter and see what happens. So if you look at the raw data again, so now if you see this query parameters, it has that parameter value. So what AWS ALB basically does is it will receive the request and it will forward the HTTPS request to this target group, which in turn points to this Lambda function, which then reads the event object, converts it into a JSON representation, and returns the HTTP response. And that's what we are seeing here. And you can see the headers here. So Mozilla is pretty good with this. Like when you have a JSON response, it automatically shows it in a well formatted uh, screen, and then you have the raw data and you have the headers, you have everything. Like you can see everything in a much, the readability is pretty good. So we are done with the first step. In the next video, I will show how to secure this ALB using Cognito or Okta or any other identity provider that supports OpenID Connect. Thank you for watching. I hope you enjoyed this video and please subscribe to my channel. Thank you.